Good evening. I'm Dr. Elizabeth Shepard, a pediatric obesity medicine specialist at Stanford and a member of the Santa Clara County Medical Association's Environmental Health Committee. We welcome you to tonight's presentation with Dr. Robert Lustig, who will discuss obesogens. I'm joined by Dr. Cindy Russell, co-chair of the Environmental Health Committee, who will host the Q&A at the end of the program. This webinar is the second in our four-part Environment and Health webinar series of 2026. Our upcoming webinars will feature Dr. Desiree Labode reviewing the health impacts of microplastics on April 28th, and Dr. Tracy Woodruff and Dr. Nick Chartres discussing corporate determinants of health and the UCSF Internal Industry Document Library on May 5th. All webinars are on Tuesdays and start at 6 p.m. You can sign up for these free events by going to sccma.org and selecting News and Events. This program will be recorded and posted on the SCCMA website on the Environmental Health webpage for later viewing. You can also view prior webinars on environment and health on the website. The Santa Clara County Medical Association is a professional organization representing more than 4,700 physicians across all specialties, practice settings, and stages of their careers. Their mission is to support physicians in delivering the highest quality care to their patients. The SCCMA works through advocacy, education, and community engagement with local, state, and national partners to promote the practice of medicine, advance public health, and protect the well-being of both physicians and patients. Today's webinar is part of the SCCMA's ongoing commitment to provide timely, relevant, and practical information to the medical community. These sessions are provided to foster collaboration and knowledge sharing across the healthcare ecosystem. Before we start, a few things to mention. You will be muted during the program, but we invite you to post questions anytime in the Q&A. We will not have live audio questions. We will take questions for Dr. Lustig at the end of the program. We will try to post resources during the program in the chat, but if not in the chat, we will make every effort to make these available on the website linked to the recorded video. And now I have the pleasure of introducing Dr. Rob Lustig, with whom I've been acquainted for many years through our mutual work in the field of childhood obesity. Robert H. Lustig, MD, MSL, is Professor Emeritus of Pediatrics in the Division of Endocrinology and a member of the Institute for Health Policy Studies at the University of California, San Francisco. He is a neuroendocrinologist and an international authority on obesity, diabetes, nutrition, and neuroscience. Dr. Lustig graduated from MIT and received his MD degree from Cornell University Medical College. He completed his pediatric residency at St. Louis Children's Hospital and his clinical fellowship at UCSF. He spent 6 years as a postdoctoral fellow and research associate in neuroendocrinology at the Rockefeller University and was a faculty member at the University of Wisconsin-Madison and the University of Tennessee-Memphis before returning to UCSF. At St. Jude Children's Research Hospital in Memphis, he worked with children whose hypothalami had been damaged by brain tumors or subsequent therapies and developed a treatment protocol for severe obesity using octreotide to address hyperinsulinemia. Dr. Lustig is one of the leaders of the global anti-sugar and real food movements to improve global health. He is the author of over 200 academic works, which connect the science of food and metabolism to the policy and politics of the obesity and diabetes pandemics. He also comments on the role of industry tactics to promote hedonic substances and behaviors and the resulting aftermath in healthcare and society. He is former director of the UCSF Weight Assessment for Teen and Child Health, or WATCH Clinic, and the former chair of the Obesity Task Force of the Pediatric Endocrine Society. Dr. Lustig was a co-founder of the nonprofit Institute for Responsible Nutrition, dedicated to reversing childhood obesity and type 2 diabetes. In 2013, he received a master's in the study of law from UC Law San Francisco. He consults for several childhood obesity advocacy groups and government agencies. Dr. Lustig's lecture, Sugar the Bitter Truth, was placed on YouTube in 2009 and has garnered over 25 million views. He is the author of 5 books, including his most recent book entitled Metabolical: The Lures and Lies of Processed Food, Nutrition, and Modern Medicine. Dr. Lustig, thank you for joining us this evening to talk about obesogens.
Oh, thank you, Elizabeth, and thank you also, Cindy and Emily and everyone out there for joining us on a Tuesday evening that's finally nice. I appreciate your indulgence. As you know, we have an obesity epidemic, really a pandemic. It's gone global. And of course, we now know that children now get the diseases of adults in terms of type 2 diabetes and fatty liver disease. So remember, those are not just the diseases of adults, but those are the diseases of aging. Those are the diseases of alcohol. And we're going to come back to that premise as we go into the lecture further on. Okay. I'm going to propose to you that we've gotten obesity all wrong. And because we've gotten it all wrong, we are uh, spending monies on things that don't work. And things only continue to get worse because we have not identified the actual substrate, the actual cause. And I'm going to try today to explain to you what I think the real cause is and what we can do about it. So that's what tonight is about. Okay, so first of all, for full disclosure, I am the chief medical officer of these companies. I am paid advisor to these others. I'm an unpaid advisor to these others, and I will not be mentioning any of them during today's lecture as they're not pertinent. Okay, here are two CNN press releases on papers that came out in Lancet in the last 2 years. More than More of the world's children are now obese than underweight, UNICEF warns. Think about that. Okay. For all these years, we were only worried about malnutrition. Now we have something called overnutrition, which is actually a form of malnutrition. We've basically traded in one disease for another. And on the other side, among high-income countries, U.S. shows slowest progress in reducing risk of chronic disease deaths. And that's because we're not treating it. We're not even close. And we don't even know how to prevent it. In fact, all the diseases that we are dying from, and I'm going to list them for you: type 2 diabetes, hypertension, dyslipidemia, cardiovascular disease, cancer, dementia, fatty liver disease, polycystic ovarian disease, depression. None of them have a cure. In fact, none of them actually have a treatment. We treat the symptoms of those diseases. So we treat the dysthymia with SSRIs, we treat the high LDL with statins, we treat the hypertension with, various antihypertensives, we treat the diabetes with insulin or oral hypoglycemics, but none of those actually solve the problem. The disease is still there, and that's because we're not even addressing the real problem. And that's what tonight is about, to talk about the real problem. So take a look here at the trends in obesity in the US, first for adults and then for children and adolescents. Notice, doesn't matter if you're black or white, male or female, old or young, the secular trend of obesity continues to rise inexorably in every single demographic. On the other side, here, children and adolescents, take a look. We have all ages, we have 12 to 19 continuing to go up. 6 to 11 also continuing to go up. But now notice what's happening here in the toddler age group. We've seen stabilization. Now, why is that? What happened starting around 2005? The answer is we got juice out of daycare. We changed the environment that these children lived in, and we were actually able to make a difference. This is an environmental insult. And we have data to show that when you fix the environment, you fix the problem. That's where we're going. So it is true that obesity is a complex problem. I'm not arguing that. And there are issues regarding energy intake and energy expenditure and genetics and lifestyle factors. But tonight, what we're going to talk about is the environment. We're going to talk about all of these things over here on the to the right. Okay, drugs, built environment, endocrine chemicals, viruses, antibiotics, microorganisms, epigenetics, and most importantly, developmental programming. That's what we're going to talk about tonight and what role they play in this obesity epidemic. Now, most people are trained by, in the concept of obesity based on the first law of thermodynamics. And the first law of thermodynamics goes like this: the total energy inside a closed system remains constant. That's the first law. I am an adherent of the first law. I do not, I'm not a heretic. I believe in the first law of thermodynamics. The question is the interpretation of that law, because like any law, it's subject to interpretation. And there are two ways to interpret the law. One is called the energy balance model. The other is called the carbohydrate insulin model, and they are not the same. The energy balance model is what pretty much 95% of healthcare practitioners and about 99% of the public believe. And that is that obesity is due to overeating. And the reason is because it's all about calories. Because it doesn't matter what kind of calorie, it doesn't matter where the calorie came from, because a calorie is a calorie. You eat too many calories, you burn too few calories, you gain weight. And in this model, the brain is the controlling factor for weight gain. Now, there's a second model, which, like I said, a few people believe, about 5% of the um, uh, practitioners, and about 0.1% of the public. And that is the carbohydrate insulin model. And that's a different model entirely. What it says is that calories are not calories, that it depends on where those calories come from as to where they go and what they do. And specifically, those that stimulate the hormone insulin, because there is no weight gain without insulin. I'll prove that to you. Take a look at any type 1 diabetic before they start receiving insulin injections, how much weight they lose, and as soon as the insulin starts, they gain all the weight back. So anything that stimulates insulin is going to drive energy into storage, particularly in fat. And the two things that drive insulin are high glycemic index carbohydrate, refined carbohydrate, starch, and sugar. And that these two are particularly egregious in terms of the obesity epidemic. And that insulin is a risk factor for chronic metabolic disease all by itself because, number one, it has metabolic effects in terms of energy storage, and it also has growth effects in terms of cell growth and division. And all of those chronic metabolic diseases that I talked about before have hyperinsulinemia as a hallmark, and that the insulin is actually a driver. Now, which of these two is it? The proponents of each of these two models have been duking it out now for about 10 years. And I will tell you right now, I never believed in the energy balance model. I believed in the carbohydrate insulin model until about 8 years ago. And now I don't, because there's a third model, and I'm going to show it to you, and it's very important for this discussion. But we're going to talk about these two models first. All right, the energy balance model. Very simple. You eat too much, overeating. You burn too little, physical inactivity. Leads to increased energy intake, decreased energy expenditure, therefore, a, a plethora of extra circulating metabolic fuels. This we could call the bucket hypothesis. Okay, you fill the bucket, and when you overfill the bucket, it's got to go somewhere, and that is fat storage. In other words, we gain weight because we eat more, burn less, or both. This is the standard mantra of the American Medical Association, the Endocrine Society, the American Diabetes Association, the Institute of Medicine, the NIH, the Surgeon General, the White House, and Congress, and the food industry. That is, you eat too much, you exercise too little. If you're fat, it's your fault. Therefore, diet and exercise. Therefore, any calorie can be part of a balanced diet. Therefore, don't blame our calories. Go pick on somebody else's calories. All of this comes from this notion that calories are fungible. They can be calories on the positive side of the ledger, they can be calories on the negative side of the ledger, but a calorie is a calorie. That's implicit and inherent in the energy balance model. Now, turns out there are support and challenges to that model. Here's the support. It is possible to lose weight on a variety of diets. So, in some ways, calories do count. And consumption of ultra-processed food causes weight gain due to overeating because of altered brain control over eating, which has a name. It's called addiction. The challenges to this model are the following. For any given caloric intake, the BMI is actually higher now than it was 20 years ago. That doesn't make sense. It does not address the role of developmental programming, which we're going to talk about in a minute. The weight loss does not last because the body defends its set point, which should not be true if it's just about calories. Exercise does not induce weight loss. There is not one study anywhere in the world's literature that shows exercise alone causes weight loss. It causes muscle gain, which is good. Okay, it improves metabolic health, which is good, but it doesn't induce weight loss. And if the energy balance model were true, then it should, and it doesn't. And finally, there are plenty of patients with weight gain without overeating. Here's an example of some of that data. Okay, take a look at the percent obesity going up with time, and take a look at the energy intake over here. It's pretty constant. Okay, and sorry, energy intake down here, I apologize, in orange. Okay, it's going down, not up, it's going down. So energy available stayed constant. Energy intake's gone down, yet obesity has gone up. How do you explain that? So the other model is the carbohydrate insulin model. And in order to understand that, first we have to explain insulin. Insulin, as you know, is an anabolic hormone. It regulates the storage of all metabolic fuels, but in particular fat. Okay, excess insulin causes weight gain. No ifs, ands, or buts. Okay, that's a given. That's a drop the mic kind of statement. All you have to do is look at patients with insulinoma to understand that, or congenital hyperinsulinism in pediatrics. Okay, all you have to do is look at excessive insulin treatment in diabetes. They all gain weight. Okay, and there are genetic variants that affect insulin secretion. They're all fat. And decreased insulin action causes weight loss, like, for instance, type 1 diabetes. So there's no question insulin is a driver of weight gain. So here's how the carbohydrate insulin model works. So here's insulin secretion here at the level of the pancreas, at the level of the beta cell. And what drives that? As I told you, refined carbohydrate and sugar right here. That ultimately leads to partitioning of energy into fat first. So this is a fat first model. And then that makes you relatively energy deficient in the rest of your body, including hunger, which drives further intake. And that's the reason for the obesity. Here, the food intake and the hunger are secondary to a biochemical process called insulin. So if we gain weight because of refined carbohydrate and sugar driving insulin and therefore energy storage. Okay, support and challenges to that. All right, the support is, well, ketogenic diets promote weight loss more effectively than low-fat diets. And that's now pretty much ensconced in the literature. If you inhibit insulin secretion, which I did, as Dr. Shepard told you about in these patients with brain tumors, we've got significant weight loss just because we dropped the insulin. And more importantly, not only did we drop the insulin and not only did they lose weight, but their diet changed. They stopped eating carbohydrate on a dime, which is fascinating, that their dietary preference changed. And of course, the current Western diet is highly insulinogenic. So that's the support. The challenge is there's this phenomenon I'm going to show you in a minute called developmental programming. And the carbohydrate insulin model does not explain that. High glycemic processed foods have other ingredients that could be at risk, causative here. And adipose fat storage can occur without carbohydrate or increase in insulin. So here are the two models put side by side, if you will. So here's the energy balance model. Here's the carbohydrate insulin model. And what you can see is here the positive energy balance comes first and the fat storage comes second. That's why if you're fat, it's your fault because this is a behavioral phenomenon and therefore the biochemical piece is secondary to the behavior. The carbohydrate insulin model, it's the opposite. The adipose tissue comes first, meaning it's a biochemical phenomenon, and that the behaviors that we see in terms of energy balance are secondary to the biochemistry. So which is it? It's neither, or both, depending on how you look at it. And I'm going to explain that to you as the talk goes. Here are 4 pieces of data that refute both of them and say that something else is going on. And no one is taking these into account. On the left is a study that was done published in 2020. And what it's looking at is basal body temperature in the United States over the past 150 years, from the Civil War to today. Okay? And it doesn't matter if you're male or female, black or white, old or young, basal body temperature is going down. You learned in elementary school, never mind medical school, you learned in elementary school that basal body temperature for human beings is 98.6 degrees Fahrenheit. Not true anymore. Today, the median is 97.0 degrees Fahrenheit. 1.6 degree Fahrenheit reduction in basal body temperature. Now, basal body temperature is a function of the fact that mitochondria can't capture all of the heat that is being given off when you burn energy in mitochondria to form ATP, adenosine triphosphate, which is the chemical energy that your body needs to run. So if your body temperature is going down, that means you have mitochondrial dysfunction. And that's actually the cause of the weight gain, the mitochondrial dysfunction, the fact that you're not burning energy all the way through. And this is a direct marker of that. Now, on the second side, on the right side, this is a study looking at animals in captivity, eating the same food all the time with the exact same cages and the exact same enrichment. It's not like they're all going out and free ranging. These are animals kept in captivity, and it doesn't matter which animal species you look at. Over the past 25 years, there's been an increase in these lab animals' weight, and they're eating the same thing they always did. So they must be exposed to something that's causing that weight gain. And if they're being exposed to that, maybe we're being exposed to that. Problem number 2. We have an epidemic of obese 6-month-olds. They do not diet or exercise. In fact, we have an epidemic of obese newborns. 4 separate studies, US, South Africa, Israel, Russia, all show over the past 25 years a 200-gram increase in neonatal body weight. So babies are being born half a pound larger. When you stick those babies in a DEXA scanner, turns out that 200 grams is all fat. So we now have obese newborns. They don't diet and exercise. So any hypothesis that you want to proffer to me to explain the obesity pandemic has to explain this as well, and you can't. The fact is that if babies are being born obese, something is happening in utero. And the question is, what is it? Well, that's where this concept of critical periods comes in. Okay, nutrition, stress, and environmental chemicals that cross the placenta and drive adipose tissue gain even before birth. So maybe it's mother's diet, maybe it's cortisol, maybe it's chemicals. We don't know. But this concept of epigenetics and developmental programming has to be factored in. I actually edited a book about this back in 2010 called Obesity Before Birth, Maternal and Prenatal Influences on the Offspring. And it's not just lab animals, it's humans too. So this actually brings up a new area of medicine, a new sector of medicine, which you probably heard of, called the Developmental Origins of Health and Disease, or DOHAD. And that's what this is. This is DOHAD. Okay. Epigenetic programming, changes in methylation status of individual genes that ultimately lead to overexpression at different times in life, at different critical windows. And these changes can persist throughout life. So a bad start can last a lifetime. That's ultimately what this is. And what are the chemicals that are doing this? Well, we call them endocrine disruptors. And you've heard of these EDCs. Okay. You've heard of Teflon. You've heard of PFAS. You've heard of a whole bunch of these, BPA and phthalates and PBDEs and, plasticizers and flame retardants and, parabens. And we're going to talk about all of these in just a minute. Okay. All of these have been shown to drive weight gain and specifically fat differentiation, fat cell differentiation, and fat cell growth. So what is an endocrine disruptor? Well, it's a chemical or a mixture of chemicals that interfere with any aspect of hormone action. And specifically, obesogens are those that drive adiposity. So some of these chemicals are toxic by altering DNA. We call those mutagens, those are or carcinogens. And those that drive some aspect of the endocrine system we call endocrine disruptors. And those endocrine disruptors that specifically drive adiposity we call obesogens. Okay. So they are environmental agents that alter energy metabolism. They disrupt specific signaling pathways that are involved in regulating energy intake and expenditure, nutrient handling, and also adipose tissue differentiation. They can be natural, like metals, like cadmium or arsenic. Okay, or they can be viruses like adenovirus 36. They can be things like prescription drugs, like, for instance, Zyprexa or olanzapine, okay, that cause severe insulin resistance and drive weight gain. They can be environmental, like insecticides or plastics or household chemicals or particulate matter, like air pollution, or they can be food components. And of course, my favorite hobby horse is this guy over here, fructose, which we're going to talk about. Okay. Point is, obesogens are endocrine disruptors, and they're out there. So where are they? Well, they're friggin' everywhere is where they are. They're in the resins, they're in the paints, they're in the plasticizers, they're in the cosmetics, they're in the pharmaceutical drugs, they're in the furniture, they're in the electronics, they're in the solvents, they're in the pesticides. They're painted on the bottom of your boat to keep barnacles from sticking to the hull of your boat. So they are in the water. Okay. And we have written these papers here specifically about these and demonstrating the data that shows that they are associated with our obesity epidemic. And these obesogens can alter many different endpoints. Okay, everything from activity and body weight to food addiction, to oxidative stress, which we're going to talk about, to insulin resistance, to changes in the microbiome, to fat in the liver, to inflammation, et cetera, et cetera. Okay? Obesogens are at the center of all of these things. Now, in order for obesogens to be a cause of the obesity epidemic, they have to precede the obesity epidemic. Because if they come after, then they can't be a cause, can they? Right? Well, here's the increase in obesogens, and here's the increase in obesity following about 20 years later. Okay, so at least from a precedence standpoint, that it makes sense. And these obesogens tend to stick around. Okay, so here's a whole host of them right here. And these are forever chemicals. You've heard of forever chemicals, like, for instance, PFASs. Okay, they don't go away. They're here and they're here to stay. Okay, and we are born pre-polluted because you can measure this in umbilical artery blood. And everyone in America has a PFAS level. Everyone. 100% of Americans have a PFAS level. PFAS, by the way, that was Teflon, okay, or C8, okay. And you can see here PFAS in breast milk, okay. How are you going to get it out? You can't, okay. Well, here's a sampling of obesogens. So call out your favorite one: air pollution, DDT, PFAS, dioxin, bisphenols, phthalates, tributyl tin, that's the one you paint on the bottom of the hull, flame retardants, okay, PBDEs, microplastics. Everybody familiar with microplastics now, right? You know that 1/200th of your brain right now is plastic. Right? Cadmium, arsenic, and all of these, insecticides, chlorpyrifos, neonicotinoids, permethrin. Okay, these are all, the diazinon, these are all used on crops today. And of course, stuff in the food itself, fructose being the primary driver, but not the only one. And then, haha, non-nutritive sweeteners. You use these to try to reduce calories, but these have adipose tissue effects all by themselves. And that may be why there are no studies anywhere in the world's literature that switching from sugared beverages to diet beverages causes weight loss. All right. So are there human data that implicate obesogens? Yes. Now, the problem, of course, is that these are all uh, 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 studies that are done, historical. They're all historical studies. They have to be because you can't expose anybody to these, and that's, immoral and illegal, and you get thrown in jail. So we have to use historical studies. We don't have a choice. Okay, but here's a host of them right here showing meta-analyses of phthalates, of BPA, of BPS, of air pollutants, of DDT. Remember, DDT went away in 1972. Okay, it's been gone for 55 years now. Okay, but the metabolite DDE is still around, and you can measure DDE in pregnant mother's urine in the Salinas Valley. And it turns out that that DDE level in pregnant mother's urine predicts obesity in the offspring at age 5 and age 11. This is work of the Chamaco study, which I am the endocrinologist on. Okay, so this is very real. Could it be that obesogens explain why diets fail? Well, in the pounds lost study, okay, people lost some weight. Yeah, okay, fine. And they've lost weight on all these different diets. And most of the weight loss occurred in the first 6 months, as you can see here. And then the weight regain. And it turned out that the weight regain was predicted by the patient's PFAS level. The higher the PFAS level, the greater the weight regain. Could the PFAS be driving the repeat weight accumulation? Well, we don't know yet. All right, now here's where things get a little hairy, and I'm going to hope you can, hold on with me. It's true that obesogens alter these hormone signaling pathways. One of the pathways, because you can see there's a whole bunch of different things. Oxidative stress, I mentioned that earlier. Reactive oxygen species, you've heard of them, okay? For instance, oxygen radicals or hydrogen peroxide or superoxide radicals, okay? These ROSs are a driver of changes in energy metabolism, and I'll show you that on the next two slides. Okay, and what they're doing is they're actually changing the enzymes that are involved in energy burning versus storage inside cells to promote weight gain. Now, in order to explain this, first we have to do support and challenges like before. So what's the support for this? Well, we have in vitro studies, we have animals, we have human studies that all support this. We have developmental adult exposures. This obesogen and ROS model actually explains the developmental programming and the epigenetics. And we have human exposure to various obesogens throughout the lifespan. All right, what about the challenges? The challenges are we don't have biomarkers. That's a big problem. The challenges are we don't have clinical studies of intervention, and we don't have we don't have any data showing that if you decrease the exposure, it results in lower weight gain. We only have increased exposure causes greater weight gain, like the pounds lost study. So those are the problems. So here are the reactive oxygen species we're talking about: superoxide, hydrogen peroxide, hydroxyl radical. These are the three. Okay. Now, in high dose, these are toxic. These damage cells. They cause lipid peroxidation, protein denaturation, ultimately cell death. But in low dose, they are signaling ions. Okay, and I'll show you that in a moment. So if you change the redox status of a cell, that is the oxidation reduction status of a cell, by increasing reactive oxygen species, it changes fuel partitioning. Okay, so the normal response to fuel is to increase reactive oxygen species transiently. And the reason is because the mitochondria make ROSs. Every glucose molecule gives off 11 ROSs in the mitochondria. You can't stop it. It's part of the deal. It's baked into the cake. You make ROSs. And by the way, that's why you have antioxidants. That's what the glutathione is for. That's what uh, 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 cysteine and methionine are for. That's what vitamin C and vitamin E are for. That's what anthocyanins are for, is basically to detoxify and to quench these reactive oxygen species that are normally given off from mitochondria. Now, when the mitochondria are overloaded, when they get too much energy, what happens is the mitochondria are making ROSs, and those ROSs feed back and they say to the cell, "Hey, I'm busy here. I can't handle all this stuff you're throwing down the chute. Okay, got to cut it out. Divert, divert." And so what happens is the cell, instead of processing more energy through the mitochondria, takes an alternate route for storage. In the liver, that becomes fat. In the brain, that becomes glycogen. Okay, a storage form of glucose, separate, that doesn't require mitochondrial function, because ROSs are made by mitochondria to inhibit mitochondrial function as an autocrine control mechanism. So an ROS signal is inappropriate when fuel is normal. When it's stimulated, that's good. But when fuel is normal, ROSs should be normal. But if you generate an ROS signal, that's going to do the same thing. The question is, where's the ROS coming from? So food consumption makes ROSs, and the ROSs tell the pancreas make more insulin, changes brain intake, changes liver gluconeogenesis, all of which lead to nutrient storage. And there's your adipose tissue. Well, here are these obesogens, and take a look. They work in different places. Different obesogens work in different parts of the body, but virtually all of these obesogens, pick your obesogen, they all increase reactive oxygen species. That's the thing that ties them together, is the ROSs. So here's the problem. You can get obesogen, you can get ultra processed food, basically driving mitochondrial ROSs, or you can get obesogens from the outside world driving ROSs. You're getting double ROS. You're getting ROS inside the cell, you're getting ROS from outside the cell. All of this means changes in energy diversion from mitochondria to storage. And ultimately, that leads to adiposity. So, concept ultra processed food is particularly ROSogenic, and those ROSs are shared among organs too. So what happens in the liver ultimately is felt by the pancreas, and what happens in the pancreas is felt in the brain. Everybody wonders how the pancreas knows how much insulin to make. It's because the liver told it how much based on the ROS generation. So redox couples are transported around the body. So what happens in the liver is interpreted by the brain as well. And they impact function in an organ-specific manner. And that leads to hyperinsulinemia, hyperlipidemia, increased appetite, and fat deposition. All right, this model, support and challenges, right? So here's the support. The circulating redox state becomes more oxidized with age and disease. And of course, adiposity does too. The changes in redox response to fuel consumption are very well documented. That's old news as well, since 1972. And ROSs impact cell function in an organ-specific manner, as I've already shown you. Okay, the challenges. Right now, this is a hypothetical model, hard to prove. Okay, and I'd like to prove it, but it's hard to do. And we have to get rid of the relevant chemicals in order to change the redox state and then show that it's the change in the redox state that induces the weight loss. That's a heavy lift, to be sure. But here's how I think it goes together. Okay. Here's diet, ROSogenic. Here's obesogens, ROSogenic. You get ROSs, you interfere with hormone signaling. These work on different organs, including the brain, to increase food intake. That's called the energy balance model. If it works at the pancreas, it increases insulin. That's the carbohydrate insulin model. In other words, they're both wrong and they're both right. They're both wrong because they're secondary. They're downstream of the problem. They're both right because they do actually impact on weight gain. So this fight between the two models is really a tempest in a teapot. And if you believe this model, it supplies a window into what you have to do to prevent obesity. You have to work here, not here. Now, how can you do that? Well, you got to get rid of the obesogens. You got to get rid of the endocrine disrupting chemicals that are driving the ROSs. Well, they're hard to clean up, and a lot of them are baked into the cake. Okay, like for instance, air pollution, ionizing radiation, PFAS, forever chemicals. How are you going to get rid of those? It has been estimated that to get rid of all of the forever chemicals would cost 10 times the GDP of the entire world for 10 years. Ain't happening. Ain't happening. So there's a certain amount of this that we're going to have to basically live with. But there is one ROS generator, and it happens to be the worst ROS generator that we actually could do something about. Want to guess which one it is? Fructose. Fructose is the biggest ROS generator, and the food industry put it there so they could take it out. All right. Can I show that? Yeah, I can actually. All right. So this is a study that my colleagues at UCSF did looking at added sugar intake and epigenetic age, which is a sign of ROS toxicity. Okay. And it shows doesn't matter if it's the Mediterranean diet, alternate health index, whatever. It's the sugar that matters. It's the sugar that matters. And when they do the models, it's the added sugar that basically goes through all the models. It's a primary driver of epigenetic age, which, as you know, is what kills you. Okay, it's the added sugar. And this one is my favorite study. I love this study. If you don't know about this study, you are missing out. Okay, everybody familiar with World War II? Everybody familiar with the fact that in World War II, sugar was rationed? Everybody familiar with the fact that ultimately that rationing ended? Well, in Britain, it ended in 1953. That's when the government decided that sugar rationing could be suspended and people could consume however much sugar they wanted. And what they did was, what happened is those people that were born before 1953 and now after 1953, they're now old. Okay, they're old enough to get chronic disease. And so a group in the UK went and evaluated the prevalence of obesity and hypertension and chronic disease in the babies that were born before 1953 when sugar was rationed and the babies that were born after 1953. Okay, so here's the sugar consumption before, and here's what happened after the sugar restriction was lifted. Everybody see it? Okay. Well, here's type 2 diabetes in the before 1953 group, and here's type 2 diabetes in the after 1953 group. Here's hypertension in the before 1953 group. Here's hypertension in the after 1953 group. In other words, if you were born when sugar was plentiful, You're sicker than if you were born when sugar wasn't. That to me is cause. That's causation. That's called an econometric analysis that basically demonstrate cause. So, in summary, my last slide, and we can use the rest of the time for questions. Neither the energy balance model nor the carbohydrate insulin model explains developmental programming and epigenetics, and it turns out that that's pretty darn important. Obesogens can explain these phenomena. Redox changes alter cellular energy metabolism because it alters the phosphorylation status of the enzymes that are involved in energy burning at the mitochondrial level or energy storage. By the way, those three enzymes that are involved are all kinases. Okay, one is called PI3 kinase, phosphatidylinositol 3 kinase. That's the spigot that lets the glucose into the cell. The second one's called AMP kinase and is adenosine monophosphate kinase. That's the signal for mitochondrial biogenesis. That's the fuel gauge on the cell. And finally, the last one is called mTOR, mammalian target of rapamycin. That's the one that decides whether the cell is going to divide or not. Okay, and redox couples change those three enzymes to store energy instead of burn it. So the obesogen redox model works upstream and incorporates both the energy balance and carbohydrate insulin model downstream. But you have to work upstream to cause a change, to prevent. So the redox model makes more sense. And fructose is both an obesogen and a redox generator. And there's epigenetics of its effects on early weight gain and chronic disease. So to me, you got to fix the food. Nothing else works. And the problem is we haven't. And this is why I do what I do. This is why Dr. Shepard told you I'm involved in a whole bunch of different projects and efforts to try to get the food industry to change their food paradigm, specifically because I think it's driving this process. And I think that until we get the food fixed, we will not see an end to this process. That's why I think that prevention is the only thing that will work. So with that, I will close, and I'm very happy to entertain any questions.
Wow. Thank you so much, Dr. Lustig, for this outstanding presentation. And you're such a gifted communicator. I've been a fan of yours for many years after I saw your brilliant medical school lecture, Sugar the Bitter Truth, which was
Oh,
mentioned
very kind.
earlier. And I had to watch it twice to understand it, but it was still engaging. It's wonderful. People should really look at it.
It's
And
it's it's 17 years old now.
still very relevant, still
Yeah,
very,
the,
really
the,
very
the
relevant.
science in it is still right.
Yeah. And, it just amazes me how you continue to expand your research and enrich, medical education for generations of physicians, really, and teach them a whole different perspective on how to look at true health and, to avoid that trap of a pill for an ill that we're always taught in medical school,
Yeah, yeah. The,
and
the
how
the
to get to
bottom line is, Dr. Russell, there is no pill for this, and there never
right.
will be.
Yeah. And also, I want to just say you're very quotable. One of the quotes I especially like is, and this relates to what you were just talking about, is prevention is not just better than a cure, prevention is the cure.
That's right.
So many lessons you've shared with us today, and I really appreciate it. So we're going to go ahead and take questions now from Dr. Lustig. And we had some questions here too. I want to start with um, uh, one of the things is you talk about artificial sweeteners and their, effects on weight gain.
Yep.
One of the things some research has pointed out is that artificial sweeteners may negatively affect the gut microbiome too.
Correct.
Can you explain a
Yes.
little bit about that?
Absolutely. So this is work done primarily at the Weizmann Institute in Rehovot, Israel, but also right there at Stanford in Justin Sonnenberg's lab, Sean Spencer and a few other people there. So this should be, near and dear to all of your hearts down at Stanford. Um, so everyone says, "Hey, diet sweeteners, no fructose, no calories, should be good, right?" Not so much. Turns out diet sweeteners are a problem not because of calories and not because of fructose. it does two other things that are a problem. First thing, you put something sweet on the tongue. Message goes tongue to brain, sugar's coming. Message goes brain to pancreas, sugar's coming. Get ready to release the insulin. But then it was a diet sweetener, so the sugar didn't come. What does the pancreas do? Does it hold or does it release the insulin anyway? And the answer is it releases the insulin anyway. And so if you're releasing the insulin anyway, you're going to gain weight. So that's problem number one. Problem number two, work from the Weizmann group shows that several of the diet sweeteners, not all, but several of the diet sweeteners, particularly aspartame and sucralose, those two are the most egregious, um, cause changes in the intestinal microbiome that ultimately lead to what we call leaky gut and ultimately glucose intolerance with gut inflammation and ultimately systemic inflammation driving chronic metabolic disease, having nothing to do with sugar, but having to do with the molecule, the diet sweetener molecule itself. So, the epidemiologic studies of sugar beverages against artificially sweetened beverages say the following. The toxicity of one Coca-Cola equals the toxicity of two Diet Coca-Colas.
Mm.
Half as bad. But half as bad is not good. Half as bad is half as bad. And, like the orange guy in the White House, how many Diet Coca-Colas does he drink? About 30 a day.
Oh, no. No. Really?
Yeah. I personally think that's where his dementia is coming from.
Mm. Wow. Another question is, somebody asked if you could show the slide again right after obesogens affect multiple organs. It lists the positive ways to reduce ROS, if you're able to do that.
Let me see.
We'll have to share a screen. I don't know.
Yeah, let me see. Yeah, you'll have to, participants can see your screen. Can you see my screen? No. Hold
Not
on.
really.
All right, hold on. Can you see my screen now?
Yes.
Okay. So where was it? Obesity.
Right after obesogens affect multiple organs,
Oh, okay.
it lists
Obesogens affect multiple organs. Yeah.
positive ways to reduce ROS.
Yeah. Okay, here it is right here. This one?
I'm not sure, but that looks good.
This is the
Well,
one.
that's obesogens affect multiple organs, and then I guess it's right after that, one after that, she says.
All right, this one. So basically what you've got is you've got double ROS. Now, in the old days, before our environment went to hell in a handbasket, you only had the ROSs from food. You had single ROSs. Now you got the food and the environment, double ROSs. And what that's doing is that's overwhelming the ability of the liver cell and the brain cell and every other cell to quench the ROSs in the peroxisome. And so those ROSs stick around and are driving the changes in those enzymes that we talked about, leading to all of these effects that lead to energy storage.
Okay. And we have a couple questions. One is, what about fructose naturally occurring in fruit, or are you referring to high fructose corn syrup and processed foods?
Right. So the molecule fructose is the same in sucrose, in high fructose corn syrup, in maple syrup, in honey and agave, okay, and in fruit. The molecule itself is the same. There's no difference in the molecule. What's different, though, is the absorption of the molecule. So if you're consuming your fructose in sucrose or high fructose corn syrup or maple syrup or honey or agave, you are basically consuming, you're getting 100% absorption because it's being absorbed at the level of the duodenum. If you consume your fructose in fresh fruit, that fructose, which is, by the way, still bound to glucose, called sucrose, that sucrose is in a matrix, that is in a fiber matrix in the fruit. And the fiber, both soluble and insoluble fiber, and you need both, and fresh fruit has both. forms a gel on the inside of the intestine, like a fish net stuffed, that is coated with kelp. Okay, and you can't, and the chemicals in the food don't get absorbed rapidly. And so if they don't get absorbed rapidly, they don't spike your glucose or fructose in your blood. That means your insulin stays low. And that means that you will maintain your insulin sensitivity and you won't turn the fructose into fat in your liver.
Hmm.
And because you didn't absorb it early, it will go further down the intestine to the jejunum where the microbiome is, and the microbiome will chew it up for its own purposes. And therefore, you never absorbed it. So even though you ate it, you didn't get it. Your
Hmm.
microbiome did. And so the sugar in fruit, as long as it's whole fruit, actually is inconsequential. It's when you turn that fruit into juice and you've removed the fiber and you've removed the sugar from its matrix that it basically gets absorbed just as rapidly as a Coca-Cola. And then you've got a problem. And the data show that fresh fruit actually inhibits diabetes and heart disease and Alzheimer's disease, whereas fruit juice contributes to diabetes and heart disease and Alzheimer's.
Wow, that's awesome.
So the fiber is the
Thank
answer there.
you. So another question is, in the Hacking of the American Mind that you wrote, you talked about sort of the differences between pleasure and happiness, and I watched a bit of that video, and it
Yeah,
was fascinating to me because it does speak to the other issue of marketing and how they get us, right?
indeed.
What is the top takeaway you want to convey to the audience, or sort of takeaway from that book and that
Okay, well,
concept?
so everybody, go read The Hacking of the American Mind. It's everything in there is still correct as well. Um, I let me sum it up for you very simply. What's the difference between pleasure and happiness? Most people think they're the same thing. What is the difference between pleasure and happiness? There are seven. Number one, pleasure is short-lived, like a meal. No, happiness is long-lived, like a lifetime. Number two, pleasure is experienced viscerally. Happiness is experienced ethereally above the neck. Number three, pleasure is taking, like from a casino. Happiness is giving, like the Habitats for Humanity. Number four, pleasure is experienced alone. Happiness is experienced in social groups. Number five, pleasure can be achieved with substances. Happiness cannot be achieved with substances. Number six, the extremes of pleasure, whether it be substances or behaviors, so substances like cocaine, heroin, nicotine, alcohol, sugar, or behaviors, shopping, gambling, internet gaming, social media, pornography. In the extreme, all lead to addiction. There's an aholic after every one of those. Shopaholic, alcoholic, sexaholic, chocoholic, you name it. Okay. Whereas there's no such thing as being addicted to too much happiness. And finally, number seven, the one that matters. Pleasure is dopamine and happiness is serotonin. They are not the same. So, two different neurotransmitters, two different mechanisms of action, two different areas of the brain, two different sets of receptors, two different clearance mechanisms. So you say, like, why do we care? So what? They both feel good. Well, here's the problem. Dopamine is an excitatory neurotransmitter, always. Every time dopamine binds to the dopamine receptor, it excites the next neuron. So the neurons fire more. Well, neurons like to be stimulated. That's why they have receptors, but neurons like to be tickled, not bludgeoned. Chronic overstimulation of any neuron anywhere in the brain leads to neuronal cell death. And those of you who are pediatricians know this because you have these kids in the neurointensive care unit who show up in status epilepticus, and the longer the seizures go, the more neurons they lose. And it behooves us to get the seizures under control as quickly as possible to save their neurons. Okay. Well, dopamine does that. Okay. So dopamine kills neurons. Serotonin, it turns out, is an inhibitory neurotransmitter. It does not kill neurons. So Dopamine is the problem. What's the way to lower your dopamine? Up your serotonin.
That's
So,
fantastic.
but the problem is that our, uh, you know, uh, our market, our society is completely dopamine fixated. I mean, if you look at the
Mhm.
top 10 exports of America, okay, four of them are addictive. Four of them are dopamine driven. And that's on purpose because that's what's causing the damage and that's what's causing the misery. So more dopamine, more addiction, more serotonin, more happiness. The problem is our food is addictive.
Wow. That's great. It applies to so many different things, and our consumption and how, everything from, social media, tech,
Yep.
everything.
Yep.
So really appreciate it. We are,
And by the
ev-
way, you
yes,
at Stanford know this, Anna Lemke, she wrote that book, Dopamine Nation. She's all over this too.
that's great. I have one more question for you. I might have two. We have a couple minutes, maybe. Someone writes, is the fructose issue better for those that do not absorb fructose very well? I believe 25% of population has transport genes that lower absorption. Not sure
I
about
don't
that.
think it's that high.
Okay.
There's definitely something called fructose intolerance, no
Mhm.
argument there, which it does lead to
Mhm.
reduced absorption. And in those patients, then when they get a high sugar meal, they will end up having diarrhea and bloating and
Mhm.
difficulties, with GI problems, because the microbiome will chew up the fructose and, generate a lot of gas.
That's
So
great.
um, there are some patients where that's true. I don't think it's 25%. I think it's lower than that.
Mhm.
But I mean, yes, that's an issue. The question is like, what do you want to do about that? Like, not
Mhm.
much.
I have just one more quick question. What are your thoughts on semaglutides? Do you have any thoughts on that, or is it just
Oh, do I
maybe
have
that's
thoughts
too
on?
long to too long
Oh, I
one
have
at the
thoughts on
end?
that. I have plenty of thoughts on that. All right,
Okay.
I'll try to do this quick. I wear three hats. I wear the clinician hat, I wear the scientist hat, and I wear the public health advocate hat. And how I feel about GLP-1s depends on which hat I'm wearing at the moment. So when I'm wearing my clinician hat, I'm glad they're here. They work. Okay. 16% weight loss. That's not chicken feed. And if you got a BMI of 35 to 40, that's a good thing to do because you will reduce comorbidities. So I'm for that. Now, when I wear my scientist hat, why do they work? Well, they work in two places. They work at the level of the nucleus accumbens in the brain to reduce reward. Well, that's a potential problem because when you reduce reward, you get suicide and depression. And we see that there's a signal for depression with GLP-1s. So that's a problem. Where do they also work? Well, they work on the GI tract to delay gastric emptying, which is basically why you get the nausea, the vomiting, the pancreatitis, and the gastroparesis, because the food's not moving through. Stomach turns to stone. That's why you can't eat. Well, that's why you lose weight, because you're starving. Well, that's not the best way to do this, but that's what's happening. All right. So that's a problem. In addition, you've heard that it causes equal loss of fat and muscle, which is true. And what else causes equal loss of fat and muscle? Starvation. And that's why it works. It's a problem. And 1/3 of people who go on GLP-1s are off it within a year and they gain all the weight back because you haven't actually solved the problem. You've band-aided it, you've bypassed the problem, but you haven't solved it. That's not good. Okay. And then finally, the public health advocate had. All right. So 16% weight loss. If everyone in America who qualified for a GLP-1 got it, that would be 2.1 trillion to the healthcare system, which is currently 4.5 trillion. So almost a 50% surcharge over what we're paying now, which we can't afford now because Medicare is going to be broke by the year 2029 anyway. And you want to put a 50% surcharge on top of that? Conversely, if we just got added sugar consumption in this country down to USDA guidelines of 12 teaspoons of added sugar per day max. If we just did that, that would result in a 29% weight loss and a savings of $3.0 trillion with no side effects.
Wow. That's amazing. Thank you so much, Dr. Lustig, for taking the time to present your groundbreaking work identifying the root causes of obesity and educating all of us so effectively in how to address this issue. It's so important for individual and public health. And I want to say you're such a brave, outspoken critic of the food industry, and we really appreciate your dedication and courage to speak truth to the powerful food interests. And I know you work with them as well.
Well,
But it's
look, you can't do it without them.
right.
Okay? You can't do it without them. I don't want to be their enemy. I want to be their conscience.
Ah, that's perfect. It's perfect. Thank you. You've been so inspiring and really appreciate it. Great talk. People will be sharing this video, and I want to remind everybody that this webinar is being recorded and will be up on the SCCMA.org website under Environmental Health Committee.
By the way, Cindy,
Yes,
would you do
yes,
me a favor? I heard in the intro that Tracy and Nick are giving their talk, I guess,
yes.
on our
May 5th.
May 5th. Can you make sure that you send me the link so that I can attend? Because
Okay, sure. That'd
I'm
be
a
great.
member of the Center to End Corporate Harm, and I'm a co-author on that New England Journal
Excellent.
paper, and I want to hear them put
Wonderful.
together.
Okay,
Okay?
so you just helped us. So join us for the next webinar.
Okay.
So
Will
our
do.
next webinar is actually a Tuesday, April 28th on health impacts of microplastics, and May 5th, join us and Dr. Lustig with a discussion of corporate determinants of health and the UCSF Internal Industry Document Library. And to sign up for that, you want to just go to the SCCMA.org website and then go to news and events and then scroll down to upcoming events. So I want to thank the audience for joining us tonight. Thank you so much, Dr. Lustig. Thank you to the SCCMA for sponsoring the series and to the SCCMA staff, Emily and Angelica, for their invaluable help doing all the behind-scenes work. And good night, everyone. Have a really nice evening. Thank you again, Dr. Lustig. That was fabulous. Just fabulous.
Pleasure.